Hello everybody, welcome to my channel. In today's video, we'll continue learning the design patterns involved in Java. In today's diagram and today's video, we will be talking about a specific creational design pattern which involves creation of objects, and because of creation of objects which gets complicated sometime in a larger application, we need to have a solution for it. In order to help us with creating complicated objects, a factory design pattern is heavily used, and further ahead we'll discuss and understand what a factory design pattern is. When we talk about factory design pattern or any object in any Java class, we have an understanding that an object is created with the help of a constructor, right? But constructor itself is very limited in terms of its capabilities when we are doing programming in Java. The reason is the constructor's name itself is having a lot of constraints, like the constructor name itself has to be the object's name or the class name, right? We cannot have multiple overridden constructor with the same signature, like in this case. I'll try to demonstrate that with an example. Let's create a class called factory demo. Let's suppose we have a simple class called point, right? A point which takes in two arguments, integer value of x and y, and it has a public constructor called point x and y, right? And this is the simplest way how we will create a point object with a simple constructor, correct? It will be an integer value, this would be an integer value, right? So this is a simple point class and this is the constructor of it. But these constructors in Java programming are limited by itself. The reason is we cannot have a constructor. Let's suppose in our point class we have two ways of calculating a point. One is a Cartesian point, another one is a polar point. For example, we also have a polar point and our client wants to generate a Cartesian point based on the input or generate a polar point based on the input. So when in terms of polar point, it will accept a rho and theta, right? See, immediately our constructor will start giving us an error telling that we cannot have multiple constructor with the same signature. It is already defined in the class point, right? Right? We are trying to define a point which can do both multiplication for a Cartesian point and for both a polar point, right? But the issue here is that we cannot have same constructor with a different name, same constructor with the same name and the same signature in Java programming. Sorry for that. So we cannot have this. There is a big constraint when it comes to constructor definition in Java. This is easily applicable in other programming languages like Swift and Objective-C, but with Java there is a little bit of limitation with defining constructor. So in order to resolve this, uh, you can take a help of an enum. For example, an enum, we call it as a point system, right? And simply we can call it as Cartesian point and polar point, right? And then we can modify the constructor of the point class to accept the third argument called as CS, or point system called enum point system called PS. And within this constructor we can define a switch statement PS. We can have a case matching. If it is a Cartesian point, then we will construct the x and y's value such a manner, right? and if it is polar point, we'll construct the x and y value using this. So doing this is absolutely fine having a switch statement, but it has again its own complexities. For example, let me first complete this code. It is giving some error. We receive x, y. Okay. So the values will won't be integer, it would be double. Correct? So this is how we'll use the switch statement, right? To get the result out of it. Right? Right? So this seems to be completely fine. The usage of enum to differentiate between and doing a switch case. But imagine your application where you first of all define the signature, right? The signature is not what the ideally point should be. It should accept only x and y because it's trying to build on. So having another third variable is unwanted, but still because of some constraint we try to implement enum. But then again there is another drawback that it gets the number of cases the switch statements increases with the number of enums that we define. So let's suppose there is a point where we defining multiple points like 2D point, 3D point, then we are defining some polar points, Cartesian points, then we have some geometrical points, and we have some latitude, longitude points. That would lead to more number of switch cases, in turn populating our constructor, right? So this is not a good way or a good approach for addressing this issue. So to resolve this issue, at this time a factory design pattern comes to help out this situation. So what essentially we can do here is instead of having a constructor with population with a lot of enum code populated with switch cases and switch statement, we can resolve it with the help of factory methods. What are those factory methods? Let's define that. Factory method. So this would be a factory method. The factory method will have a public access modifier, right? Public or private. It will be public modifier in most of the cases, and it will return the same object, the point class object, which it is trying to create. The point class object, right? Then it would be have a name, Cartesian point, right? And it will accept double A comma double B, right? And its implementation will be the same. It will, let me cut this code from this place and place it here, right? And it will return this object, correct? The value will be A, the value will be B, right? Right. So another advantage is that with the help of this factory method, Cartesian point name, the client calling this point would be aware what kind of a point is going to be returned, right? Whereas in this, we just simply pass a double of x and y, and double of x and y does not give any idea to the client calling this constructor method what kind of a point it is going to create. So these are the advantages of factory method, that it helps give clarity on what type of objects we are building, right? And it is heavily used in creating builder design patterns also, and it is heavily used in abstract design pattern also. Let's now create a method, a factory method, which will generate a polar point, right? The polar point obviously will accept a rho, then it will accept a theta, right? Right? Our x would be this simple mathematical. Let me copy this, copy paste this value, correct? And our constructor basically will now don't need any enum, right? We'll simply populate this dot x is equals to x, this dot y is equals to y. Actually we don't need the point method itself, we just need two factory methods, and the method constructor will generate based on the row value for polar coordinate, polar point. We'll accept the theta, so theta, right, and return this, right. Right. So this is how the factory methods are helpful for creation of objects with multiple constructor signatures, and it is heavily used in builder design pattern also, which we can look at in our next video. Now let's go ahead and demonstrate this particular example. So let's say a client 1 wants to get polar point. So what he can do is he can expect a point object, right, and call new point dot the factory method polar point and pass in 5 comma 4 as its argument. 4 point double, because it's a double, we'll expect, right. Similarly, let's suppose there is a client number 2. He says, okay, I wanna request for Cartesian point. So we can, and the client will be aware, okay, he is going to expect a Cartesian point. Client number 2, this will be point number 1, point number 2, right. Let's get rid of some of the syntax errors. Okay, and let's build a toString method so that we can output it to the console. Source section, go to generate toString, not found. Let's generate a toString on our own. Public toString method, it will return a string value, right. Return, right. So we have a toString in place, so let's go ahead and print the point one's value to string, and same thing for point number 2 to string, correct. See, essentially with this, yeah, with this we have resolved the error, or resolved the process of coming over with the constraint of constructors, right? We can have this factory methods which will in turn create the object, so it will basically take care of object creation and return us that object, right. That's why it's called factory method. So I hope you've understood the topic. This is how this factory design patterns is used. It is heavily used in builder design pattern, where we need to build a large complex Java object with multiple methods. So if you want a fluent API kind of a structure, we can use build method and the factory methods to return and take care of the object creation part. So, and essentially this will also avoid us to overcome the usage of enum, right, as a third argument, which can lead to a lot of constructor code pollution. In order to avoid this, factory methods is heavily used. Thank you for your time. I hope you have understood the video. If you have understood the video, like this video series, I have been creating videos regarding functional interfaces for Java 8, Java 8's version, which is part of functional programming. Then we also discuss about multi-threadings like runnable and callable interface. And we also have a few videos. I also have uploaded few videos regarding the proxy protection, proxy design pattern, and also one of the videos is discussing about the optional. So if you are aspiring to become a good Java developer, I will recommend you to go through those videos. And if you like the videos, hit like button. And in case of any doubts, please comment or your doubts in this comment section. I'll try to connect with and read all the comments and get some solution out of it. Thank you for your time. Have a nice day.